working as an assistant professor in Department of Mechanical Engineering, Walchand Institute of Technology, Solapur. Today we will see the convection boundary layer. Learning outcome. At the end of this session, students will be able to know what is boundary layer. Boundary layer. Suppose this is any plate. This is any plate for heat transfer, nothing but surface. So this is the convention to represent the surface. The surface is at suppose temperature Ts, okay, and the fluid which is flowing over the surface is at this entrance. So how the fluid flow is represented by these arrows having uniform velocity. Uniform velocity, suppose it is u infinity. It is called as free stream velocity. In simple language, boundary layer is the region in which there will be measurable influence of viscosity. That I will explain now. So when any type of fluid, it may be air, water, oil, refrigerant and so on, fluids are flowing over this surface, then at any cross section, suppose I will take the cross section somewhere here, okay. Now the air stream which is in contact with the wall, what will be its velocity? The layer of fluid which is in contact with the surface, yes, obviously it will be zero velocity. As we move away, means the fluid streams moves away from the surface, there will be increase in the velocity of the fluid, okay. And it is found that after certain distance from the surface, the fluid will have the same velocity as that of the free stream velocity, okay. So it becomes suppose equal to fluid free stream velocity somewhere here. Then this region is the boundary layer thickness, okay. So you will get the velocity boundary layer profile in this fashion. This will be velocity profile at this location. So all the fluids in this region will have free stream velocity, whereas in this region, the region near in the boundary layer, it will have the less velocity, obviously. So if I try to draw such type of velocity profile along the length of the surface, then this is the suppose surface, okay, and this is the entrance. I will get now what I will be doing, I will be joining all these boundary layer thicknesses at this location. Suppose it is somewhere here, this is like this one, okay, here it will be in this fashion. So all these boundary layer thicknesses, if I try to join, then this profile is called velocity boundary layer, in brief VBL. You will get the velocity boundary layer, okay. Now these boundary layers are getting separated after certain movement along the surface. We will assume somewhere here there will be disturbance in the or the separation of boundary layer from the surfaces. Means what? The boundary layer will be like this one, somewhere here, somewhere here, in this fashion. So this becomes your turbulent flow. Up to this point you can consider this flow to be laminar, and after keeping some gap it becomes turbulent in nature, turbulent flow. Now the region between laminar and turbulent is called transition flow. So this is transition flow region. Okay, so the flow of fluid over the surface will have up to certain distance laminar flow, next transition flow and turbulent flow. In the turbulent region, it is observed that in some thicknesses the fluid is stationary, almost stagnant, means velocity is equal to 0. So the mode of heat transfer will be by means of conduction. So this will be Q conduction and later there will be Q convection. Okay. Now in the same manner we can go for thermal boundary layer. Okay, thermal boundary layer. Suppose this is the surface and this is the temperature of fluid at the entrance. It is once again T infinity, surrounding fluid temperature. At certain distance, if we start measuring the temperature of these fluid layers, then this layer which is in contact with the surface, where surface temperature is greater than free stream temperature. So the layer which is in contact with the wall will have T infinity temperature, and as we move away from the surface, what will happen? Yes, its temperature will go on decreasing and you will get this temperature profile. Okay, so it is observed that at this distance the temperature of fluid becomes equal, this was Ts and this becomes T infinity. The fluid layer in contact with the wall will have the same temperature, it is Ts, and it, as you move away from the surface, its temperature goes on decreasing, it becomes equal to T infinity at certain point. So this is called thermal boundary layer thickness. Thermal boundary layer thickness. Similarly, at a different cross sections, if you try to draw these boundary layers, okay, and from these all free stream points, if you draw smooth curve, then this is known as thermal boundary layer. So these are the two different boundary layer in the convective heat transfer mode. Now these two boundary layers can be understood by using the Prandtl number. If Prandtl number is equal to 1, its meaning will be that the velocity boundary layer thickness and thermal boundary layer thickness will be same. If Prandtl number is greater than 1, then TBL will be greater than VBL. If it is less, VBL will be less than TBL. So in this fashion you could differentiate the boundary layers. Now what is the importance of this boundary layer? When you want to measure the velocity of the fluid over the plate, and if the measuring tip is above the thickness of boundary layer, then you will be getting the free stream velocity. Similarly, if you want to measure the fluid temperature and the sensor is in the boundary layer thickness, then you will be getting that particular temperature, otherwise free stream temperature. Okay, understood? For more study, you can refer Heat Transfer by Sengel. Thank you.